Hello and welcome to Advancing EV Battery Potential R&D Approaches for Anodes. My name is Jill Pestana, and I'm the founder and CEO of Pestana Solutions, the creator of Across the Nanoverse, the YouTube channel, and I'm partnering with Micantis to add these resources to your life to present this information. And I really appreciate you tuning in today. If you could share a bit about where you're tuning in from. I'm located in Santa Barbara, California, but I'd love to hear where you're from. I tend to get people from around the world in these webinars, so I always love to see that. And today we're really going to hone in on R&D approaches for anodes, but I have to tell you that this also applies to cathode materials as well. So whether you do research on battery cells or packs, or maybe you're at some part of the industry, I'm sure this will be helpful for you in learning a little bit more about the tools and techniques that are the state of the art in this field. And so I do want to say before we get started that I do have already some resources for you in the link in the description. For those of you who are tuning in who have missed the live recording, this will be recorded and on YouTube. Just know that you can at any time submit your questions through this form. So in the description or in the comments on LinkedIn, you'll have a link to that. I'll mention that at the end. Don't you can wait until the end to do that. And also throughout this presentation, you can submit your questions in the comments, and I will answer them live in a Q&A at the end. And also, if you find value in this presentation, in the spirit of Thanksgiving, which is celebrated in the United States later this week, consider to give back. My friend Evelyn, who's a fellow scientist, is going through cancer treatment, and her GoFundMe link is linked below. So I'd really appreciate, again, if you find value in this, consider giving back. And as we go into this topic of conversation of R&D anodes, I just want to say too that I'll speak towards a technical audience, but I do, if you have questions that are more of general questions, feel free to reach out and I'll answer those as soon as I can. So let's get started on this presentation. All right. So first I'll go through a bit about my perspectives on EV battery development challenges before going into specifically challenges in EV battery R&D for anodes. Then we'll talk through a couple actual case studies of information from HPPC's testing, as well as anode capacity loss study. And then finally, we'll end with some future directions in EV battery R&D with data analytics, and wrap it up with, like I said, with a Q&A. So when I was starting out in my career, I was doing R&D on silicon dominant anodes. And at that time, I was focused mostly on component manufacturing and cell production. So I was in a small R&D company developing battery anodes, but also the cathodes and the electrolyte, every component inside of the cell. And I was only looking at this picture. And a big part of my job was the data analysis, the results we were getting from our experiments and analyzing that. And I found how important it was to get accurate data and be able to analyze that quickly to get results and continue researching and understanding and improving the battery performance. After a few years, I went into consulting, and I worked for a boutique consulting firm where we focused on outside of the cell, for the most part, into the battery pack, the validation and abuse testing of packs. And this was super interesting because then we were looking at the data across not just inside of the battery cell, but how that influenced pack performance and design. And again, this data picture was forming in my mind of, wow, there's so many aspects to battery data across this part of the battery value chain. And then more recently, I was working as the lead of battery consulting for North America at Accenture, which is a large consulting firm. And here I was supporting Fortune 500 companies across utilities and battery manufacturing and high-tech companies, just all sorts of companies that were using battery technology, developing battery technology, and looking at the challenges across the formation of the battery value chain and supply chain. not only in North America, but globally, it was clear to me that there was a lot missing in the data picture across all of these areas. You often had people within the same company who were so focused on, say, raw materials, they weren't connected to the people doing pack analysis. Yet, perhaps there's some value add if both those parties were able to see the data and use it to maximize the value from it. And that's just within the same company. Imagine, different companies working together, and with the legislation like the EU battery directive in Europe, we're seeing more and more a need for battery material traceability and reporting and compliance of that information. And so data is not just a nice to have, a huge value add for the company, but it's also being more mandated by regulating bodies, both in Europe, the United States, and other countries as well. And so when we focus now on battery anodes, now let's put ourselves in the shoes of an anode scientist, and maybe you are an anode scientist. There's so many different parameters to consider when it comes to battery performance. And here are just a list of a few. You're thinking about the anode capacity, the low voltage potential of the anode material, whether it can have a long cycle life, it has a high coulombic efficiency, it has fast lithium diffusion, thermal stability, low lithium plating risk or sodium plating risk if you're using that chemistry, right? There's so many different aspects of performance that a battery scientist and engineer needs to consider as they're developing this technology. And just to, set the context, if you don't really know what an anode is a thin layer of material inside of batteries called it's the negative electrode, we call it. So it's when you charge up a battery, the lithium is stored in the anode. And when you discharge the battery, the lithium goes outside of the anode to the cathode. So it stores lithium, and it's a huge material in the battery. It's a very important, necessary material in the battery that enables higher battery performance. So you can only imagine when it comes to, gathering data of the anode is super critical when it comes to improving and understanding battery performance. And I wanted to provide you this prompt, so feel free to, take a screenshot or write this down. But if you want to dive more into anode performance parameters, I found just using this prompt on like ChatGPT, one of those platforms, you can learn a lot about these performance. Take it all with a grain of salt, as these are AI tools are performing, but you can really dive into what the key challenges are with these specific performance parameters and design solutions. So I want to encourage you to explore that AI technology, but again, take it with a grain of salt. Not all of that information is super accurate, but it can get you started in exploring this topic more. So now I want you to put yourself in the shoes. Now you know a few of the performance parameters of anodes, and I want to put you in the shoes of a battery engineer who's developing an anode for EV applications, so for electric vehicles. You work for an OEM and you are selecting a cell with an anode material for a high-performance sports car battery design. So what anode performance properties would you be prioritizing in this circumstance? Now put it in the comments what your thoughts are, which performance parameters are most important in the context of the application of a sports car. And yes, I would love to see you in the comments if you could post that, if you're brave enough to. If not, think it in your head, what could that performance parameter be? So there's so many different performance parameters worth prioritizing. One could be energy density, so that you can pack the battery in a tight space and have it lighter weight, but still have that powerful punch for that acceleration and torque you need to power your car. You can also prioritize the anode capacity, making sure you can fit as much lithium in that anode as possible. Yes, Daniel, I love your comment. But power, yeah, that's definitely a great performance parameter. And power has to do not just with the energy density and capacity, but also with the rate of ion diffusion through the anode material as it's discharging. You also want to have an anode with low impedance throughout cycling, both electronic and ionic conductivity, and also low cost. When it comes to batteries, there's always so many trade-offs in these different performance parameters, and cost is one of the major ones that cause us to have to really confine our battery anode materials to more abundant materials, and safer materials as well. So there's a ton of considerations you can see when it comes to developing and analyzing and improving anode technology. And this is why gathering the right data for your chemistry is super important. You want to make sure that you're valuing the things that really move the needle when it comes to anode performance. And having the right tools and techniques to do so is what I'm going to be talking about today. Because let me tell you, the tools that I was using in grad school and even in my first job as an R&D scientist, those are outdated at this point. There are so many better options today. So when it comes to selecting this anode material for a car, there's a lot of different types of anode materials on the market today. Here's just a couple examples if you can recognize. Does anyone recognize what materials these are showing here on the left or on the right? So on the left, you have graphite, layers of graphene where lithium can intercalate between those layers. And then on the right, you have lithium titanate, which, if you know, it's not really used in electric vehicles. So today, electric vehicles mostly use graphite anodes with a little bit of silicon sometimes, we're seeing. And so as you can see, going through this exercise, there's a lot of challenges in selecting the right cell and performing quality assessments on the cells itself. So from a supply chain perspective, with the geopolitical instabilities and limited regions where these materials are coming from, securing a cell supply chain is really challenging for OEMs. You also have the complexity of, if a company is securing that supply chain, are they forming a partnership or a joint venture with a company, or are they buying different companies to establish their supply chain security through a vertical integration? There's different approaches to that. And then with the geopolitical instabilities, of course, many of which, it's hard to predict exactly what's going to happen, especially with the new presidential administration and what that could mean. And so that imposes risk on the cell supply. Also, OEMs are challenged when it comes to the IP around the cell. So when you're in a joint venture with, say, an Asian cell manufacturer, like a lot of the US automotive companies are doing, there's a question as far as who owns what IP when it comes to cell manufacturing and the cell design. And with that, sharing information between the manufacturer and the OEM can be a challenge. So cell designs are often highly confidential, and even the manufacturing can be confidential as well. And so understanding the data around cell IP can be really challenging or just inaccessible at all. You can't access that information. And then when it comes to cell modeling, right, you need data to inform the cell modeling and use that for battery aging models to expedite testing, because you could just simulate a test. But there's challenges because there's often not enough data, because maybe you don't know the manufacturing process or the cell IP portion, or you don't know exactly the raw material refinement process that the materials went through before they're in the battery. So it's difficult to model these cells and understand what data is most important to inform these models. And then finally, from a cell QA perspective, checking the quality. It can be really tough when you're having a throughput of millions of cells a month that you need to check for safety. Now, you wouldn't check every single cell, but you would check different batches of hundreds to thousands of cells, perhaps per month. And when you're doing this quality check at different locations, because say you're a global products company, you have operations in China and Vietnam and Mexico, wherever you may be, you need to have visibility over all of those sites and whether they're performing those quality checks to a certain level, a certain standard uniformly. And that helps prevent recalls and whatnot. So there's a huge data challenge there to make sure that you are not just producing quality cells, but reducing any kind of liability risks. And so as you can see across all of these areas, there's a huge need for data management and analytics across this battery value chain to support the OEMs and additional stakeholders in overcoming these challenges. So you need traceability, you need to maximize the value that you're getting from your data. Margins in cell manufacturing are very low, but there's a lot of data that and value that can be extracted that can help with the value of your product that you're making. And in addition, bridging silos is the big one. So when you are able to have that kind of data visibility in your operations, you can bridge between silos and exchange that data for more value in your operations. So we have a lot of challenges going on, from development to commercialization of different cell technology, from material limitation and innovation needs to the safety and thermal management and degradation issues of the cells, to the testing and data analysis constraints. And then you have issues with commercialization when it comes to scaling your operation and reducing costs and any kind of environmental considerations. So there's always trade-offs when it comes to tackling these challenges within a company's operations. And knowing what to prioritize and when becomes very important from a management perspective and leadership perspective, especially as many of these OEMs are transitioning from producing purely gas-powered vehicles to producing electric vehicles. And when I'm talking about an OEM, an automotive OEM, we often think just about the consumer cars, but we also have cars for, mining, heavy duty equipment, and that's a whole other area too that's electrifying. So there's a huge picture here as far as the different trade-offs and limitations and the need for data visibility and using that to help with innovation and communication. Now, working within these companies and with these companies, I've seen a lot of tools that are used over and over again. And a lot of these are outdated from the perspective of there's better solutions on the market today that are really helping the return on investment. So with different battery data and management and analytics solutions that are on the market, there's a high cost for labor because it takes so long to analyze and manage this battery data. People are manually creating graphs, manually emailing data back and forth. And it's oftentimes these platforms aren't specifically for battery data. And so you're having to create a lot of functionality within the platform itself. Like, I've created so many calculators using Excel, but it takes so much time to create those kinds of calculation devices, or programming Python to do your data analysis. So there's issues with that. And then if you have a turnover within the company, and say the person who programmed Python to do the analysis leaves, who's going to take the reins on owning and updating that platform or even learning it? So you don't want to lose your data or your systems just when somebody decides to move on from the company. So you also, when it comes to these platforms, it's hard to integrate them across your operations. Sometimes some of them don't have real-time updates, or it takes somebody manually updating it every morning to update the platform, which can take a lot of time. And there's also security and accessibility concerns from your team. And it's often a high investment if you want to create a tool from scratch in your operation. So maybe you want to program a software yourself, which is nice to have that kind of control over something, but it could take years to create something that truly works for your team. And that takes a lot of time and money when you want to innovate fast, right? So let me introduce you to Micantis if you haven't heard this before. This is the kind of state-of-the-art platform that I'm referring to that really has the bells and whistles needed to do battery data analysis and management. And I'm going to talk through a couple workflows using this platform to just illustrate what this state-of-the-art battery anode or cathode data analysis looks like now within companies that are leveraging this platform. So just to give you an eye on what this platform is, this takes data from across the company, from the ERP system to data loggers, battery testers, process controls, and spreadsheets. It puts it into one place, this platform, And then from that, you can do all sorts of things to manage and analyze this data. You could graph, you can create reports. There's different workflows you can do, analysis tools, modeling tools, and you can even connect it through an API if you still want to use Python or other like software tools to further analyze, or if you want to use an AI plugin to analyze the data. There's so many potential opportunities to expand on this platform internally. So this is really just that hub, and not just that, but if you have multiple sites, every site can still get access to this. It's really scalable with the company. So whether you're an early stage R&D company with just a few tens of or hundreds of cycling channels and you want that analysis on site, or if you're a global company with multiple sites in different countries and processing millions of cells, right? This can work for that as well. So it's flexible, scalable to meet that need. Now, I want to get into a couple case studies using this. So there's the first test is the hybrid pulse power characterization, HPPC testing. This is a type of technique that can test the power capabilities. I saw somebody wrote, the anode needs to provide power for that sports car. So this is the kind of test that you can validate if the cell can perform that way and it maybe improve that cell. So picture it as if you have a battery you're testing, and it's like you're flooring the gas pedal in your car. Or I say gas pedal. Oh my goodness, you guys, I I need to improve my nomenclature around vehicles. The accelerator pedal, I guess we call it. So you're pressing the accelerator pedal, moving the car forward. But of course, HPPC testing is not the full amount of testing that needs to be completed. There's a lot more, but this data can be extracted from this test. And let's talk a bit about the workflow that we can use for this test. So first, all the cell data from all the cells you're going to be testing can be stored in the Micantis platform. You can see number one, you have a nice sheet of all your cell data organized in different customizable columns. And then the second step is to create your test plan, which you can do in the platform as well. So you can specify which groups of cells are being tested to what protocols within HPPC testing. And then while you're running the test, you can check the real-time status of these cells on the testers to see how much time until this completes. You can even get automatic alerts to your phone through text or to email, whatever you prefer, to let you know when an issue has arisen with the testing or if the test has completed, so you can address those things promptly. Which you never want to have a huge test that runs for, HPPC test doesn't last that long, maybe 12 to 24 hours to complete for a cell. But for the tests where you have like months and months of cycling, it's such a bummer when it messes up in the beginning and you don't notice it for like a week later or even a day later and you lose that time. So this really provides that visibility. So then in the platform itself, it actually has a tool to do the analysis for you once you have the data. And it only takes, 1 to 3 hours to do this at most, I would say. So as you put in your data into this, it automatically, you select the tests that were just run, they automatically update into the analysis here. And you can see there's a few different icons on the left side of the graph that you can change the view of your data. And these graphs are customizable. You can change the X and Y axis and really look at what you want to see. So this is just showing a depiction of what an HPPC test looks like. The blue is the voltage and the orange is the current that's being applied to the cell. So you can see the current is going downward spikes, which means you are discharging the battery in different pulses of different increments of current. And then the voltage of the batteries decreasing corresponding to those pulses. So that's how an HPPC test works. You apply that current pulses to simulate flooring that accelerator pedal. And over time, you could see the battery voltage decreases. Now, when I was at a conference about a year ago, a battery conference, and I met somebody from the Toyota Motor Institute who was doing HPPC testing for their cells. And it was really interesting, the conversation I had with him, because they actually found that only looking at a short voltage window with HPPC was meaningful enough to get the data that they needed. So instead of performing HPPC on the full, from 4.2 volts to 2.75 volts or whatever voltage range you're looking at, they only looked at maybe a window of 1 volt delta, and were able to extract value from that. And so what this kind of tool enables you to do if you're doing high volume HPPC testing on a lot of cells is it can help you identify those trends quickly, and so you can make the most out of that. And let me just go to the next slide where you can see this key data, like the voltage drop of during each pulse, the internal resistance, and these are things that are calculated based on the raw data. So normally if I was using Excel to do this, I would have to build in a calculator and basically manually calculate all of these points. But what the Micantis software can do is you can preset these calculations, and then they will automatically generate those points from you, so you could quickly look at your data and understand, what are the differences between the different cells, what's the performance. And this is exactly what I mean by you can pull out that internal resistance data or the voltage drop or whatever you want from that raw data and put it into a customizable table that you can then analyze at a glance. So I'm walking you through, all these different steps. All this data is just transferred into this automatically. You can have it preset to show the data you want. And then when you're going through this, the time you're spending is just time you're spending looking at the results and drawing conclusions from that. So you can sort and find data easily, filter out data that you don't want to see. And then here, of course, is the results of the HPPC test, one of the graphs you can do. And you can modify the axes. I am like stumbling over my words here. So you can modify the axes in the program to show what you want. And then, oh my goodness, this is the tool that I wish I really had, which is it automatically generates a report through the program. And so you can just click the button, put your data in. If you, sorry, let me back up. So you can create a report template ahead of time of how you want your data to be displayed. And then as you run these tests of cells, you can just click the button and it'll automatically transfer your data into the template for the report and generate these. So you can report it in PowerPoint or CSV file format, whatever your stakeholder wants to see, whether it's a manager at your company or if it's, a customer. If you're doing battery tests for a customer, you can just generate a report with custom branding and everything. So the total time to do this HPPC test with a platform state-of-the-art like Micantis is just like 1.5 to 2 days, because it's so quick. And most of this time is just the actual test itself. So with Micantis, you get the automated testing, analysis, and reporting all in one platform. You save time, and this HPPC data is now stored in the platform, and so you can correlate it with other tests you're running on similarly designed cells. And that can create, more value from the data that you're looking at. And again, you can have multi-site data testing visibility. So if you needed to share this with a team in another country, in another state, another city, even just another part of the building, they'll be able to see it. So now I'd love to talk more specifically about a really cool research technique that was used for silicon anodes. And this is to measure the capacity loss over time with anodes, but it could be used to do much more than just that. So I'll let your scientist brain think through maybe how this could be applied in your system, especially if you're using an anode material that as you're cycling it, there's a weight gain in the anode and or on the cathode that you can actually measure with the microbalance. So silicon is a really interesting anode material because it is extremely high energy density compared to graphite. It's an order of magnitude more. So instead of around 300 milliamp hours per gram, you're getting nearly 3,000 or more milliamp hours per gram. Those are just rough estimates. So super high energy density, but because of this, the types of analysis you can do on it are pretty, offer new opportunities. And so this is an R&D approach that I'll dive into to measure the capacity loss of silicon anodes over the cycle life to draw correlations between things like if you wanted to try testing different types of silicon active material or different silicon anode design or different testing parameters like the voltage window, the cycle rate, the temperature of the cells, you can use this technique to do that. And for the test protocol overview, I really spelled it out because I don't want to lose you on this. You can do it with coin cells, which is the test format that I used when I was doing this. And I would say coin cells are probably the best because you can still measure them, but they're smaller in size, easier to measure, and also it's a more replicable cell format than, say, a pouch cell that's single layer, though you could potentially do that too. You want to measure the anode when it's pristine, fresh, just made. After you punch it out for your coin cell, you weigh it, and then you weigh the anode after the cell has been cycled. And you use various groups of cells cycled to different cycle numbers, whether it be 1 cycle, 20, 40, 80, whatever intervals you want to use. So after you cycle the cell, you rinse the anode, and then you dry it out, and then you weigh the anode itself. Now, because silicon has such high energy density, the weight change of the anode before cycling and after cycling is the amount of lithium that's trapped in the anode, especially if you discharge the battery before you disassemble it. You're getting the residual lithium that's stuck in the anode, which could be the SEI layer and such. So there's a lot of cool properties you can explore through this technique. And so now let's think about the workflow for this. This is a little bit different because you're just doing a standard, cycle testing, but let's go through this. So first, you have the data of your cells stored in Micantis. You upload that information, and then you create the test plan for cycling these groups of cells to different cycle intervals. And then as you're testing these cells, you can check on the status. And this, when I was talking earlier about, getting that real-time status is really helpful in case something goes wrong during tests and you have to start again, right? So if you're testing a cell for more than 30 days even at a time to get to the thousands of cycles, you can be alerted if something goes wrong and immediately correct that and view that in real time. The second step after you're running your experiment is you can input the metadata from your cells and these weight measurements into the platform. And then you can configure the columns to automatically do all the calculations for you. So when I've done this, I was using Excel, and I had this massive Excel file where I would input hundreds of cells information in by hand. I had multiple tabs and sheets on the Excel file that looked at different, graphing different properties. And there's so many calculations you can do with this mass difference. And you look at the Coulomb counting, you look at the voltage ranges and everything like that. So in the platform, you can set it up so it automatically stores all of this data. It performs the calculations for you. And even if you use advanced analytical equipment like this microbalance, for instance, is a digital microbalance that you can connect to, say, an Excel sheet or a sheet, you can have that automatically import into Micantis, which saves time because it takes, let me tell you, it takes so long to weigh hundreds of anode materials. And so once the cells have completed cycling, or even in the middle of it, you can go in and look at that cycle data and organize that. So here's, a view of the Micantis platform when you're graphing the cycle data. This is all like fake data. So, take it with a grain of salt. It's just inputted there for this demonstration. So you can generate these cycle graphs in real time while the tester is active. You can even hone in on a specific cycle range. So if you look closely at the bottom there, you see this is just cycles 0 to 20 that we're looking at. And here's a multiple, you can compare them at the same time. And then you can easily select too between viewing options like charge and discharge on the Y and X axes, or I guess that would just be on the Y axis, but you could change the X axis as well to look at each cycle itself, say current versus voltage or whatever you want to look at. So as you're cycling these cells, you can look at, okay, after 20 cycles, after 100 cycles, 200 cycles, 500 cycles, easily visualize that. And then, like I said, automatically that data from the cycling is being put into these tables that are showing your results, and you can graph that information too. And then finally, once you've computed all the data that you want, you can have that automatically generate a report. And so the time savings for this kind of project is so massive when it comes to that analysis, because these kinds of projects take months and months to complete, but the data analysis can take sometimes even more than the cycling time itself. So really expedites that to get you the results. And so again, it's automated, it saves you time, it's flexible with the customizable data table showing you auto calculations. And also, it gives your team visibility on the status of your project. So, like if you're reporting in weekly meetings, hey, my cells have cycled 20 cycles, 100 cycles now. You can easily show your team where your project's at. So this is just a couple of applications that platforms like Micantis can do, and that are really, delivering the state-of-the-art results that the industry needs. There's so much more that's trending right now when it comes to battery data analytics. So I want to talk about in the future, what should we be expecting? One of the projects I worked on at Accenture had to do with a high-tech company exploring whether they can use high-performance computing, or HPC, for material development and analysis, as well as material discovery for batteries. And we're seeing more and more companies coming in. A lot of them are more early stage, but they're already driving value for doing these complex algorithms to invent new materials, analyze new materials, and having the thing that I tell people who come to me and have said, I want to start doing AI to develop my battery. Where should I start? Or how can I do this? I say, first thing is you need to train the model that's going to be doing that analysis for you. And in order to have a model trained to do that, you need to have a pool, a data lake of this precise data that you can feed into generating this model. And so a platform like Micantis that can store all your data can integrate with the API to then funnel that data to create these models to do AI and machine learning for your battery R&D. There's also, it's in the very early stages, but talks of quantum computing for material discovery, which we're a ways off, I think, from this, but companies are thinking about it and working on it. And then, like I mentioned in the beginning, how regulations are coming out to do traceability of batteries. And so there's a need for the battery data to inform these kinds of requirements, but overall just add value across an operations and eliminate the silos. And so a foundational platform like Micantis for data management and organization across operations is becoming more and more of a necessity, not just for like reducing the R&D time and cost to keep up with the innovation and everything, but also to leverage these advanced analytical techniques like AI and machine learning that are coming on the market. And starting to use these tools now and starting to explore their use cases in your operations. That's what so many OEMs and high-tech companies are currently doing. So when you're even in the R&D stage, right, you want to start exploring these tools so that you can keep up and know the latest and be able to inform your customers of an understanding of your cell technology. Very exciting stuff in the world of battery data. So thank you so much for listening. I'll take Q&A now, but I just want to say too, we're going to have an upcoming webinar next week where we're really going to show an introduction to the platform. So here I just shared a couple use cases, but we'll talk more about the history of the company. You'll meet the team and more information about the platform there. So use that QR code with your phone if you want to go, and it goes to my link tree, and you can register for that webinar in the top link there. And also, we're attending AABC 2024 in Las Vegas in a couple weeks. So let me know if I'll see you there. We have a booth, which is booth 506, for those of you watching the recording of this information may be out of date, but still want to get that information out there so that we can see you there. And I'll take any questions if anyone has more to ask around battery data. Yeah, thank you so much for tuning in, and feel free to message me. My email's there as well, jill.pestana@micantis.io. And what's really exciting to me about these kinds of data tools is we're just at the beginning of the tools itself. This is a new field. These are new tools. There's really, not much out there, but these are already, like, different companies are already using them. And we're seeing companies from large product manufacturers who manufacture a product that includes a battery to, cell manufacturers, to battery testing companies who are just performing tests as like a third-party testing site. There's so many types of companies that are investing in this kind of technology to speed up their innovation and give visibility. So here's a question I have about from Daniel, that he switched more towards battery raw materials and manufacturing, but always interesting to see advancement on the battery testing side. Yes, exactly. I think when it comes to even raw materials companies, right, they're having to test batteries and cells. And a lot of the companies selling raw materials are either partnering with companies to manufacture cells with the raw materials, or they're developing their own pilot manufacturing lines for those cells. And so for companies like that, they need visibility not just on the raw material processing and having that traceability of, oh, we did this type of processing technique for this material, but then the visibility of the cell manufacturing process and the end result of that cell performance. And so the data picture for that kind of company is not just the raw materials, but the cell manufacturing process and then the ultimate performance of those cells. And then if they partner with other companies and are testing different materials to, say, pair a cathode with an anode or an electrolyte with a cell design, right? Having more data visibility adds value to all the stakeholders involved in that project. So yeah, I'd love to hear more. Does this perspective resonate with you? Feel free to add that in the comments. I really would just want to generate more conversation through this. And again, if you do have more questions that you don't want to share here, feel free to visit the link in the description. I have a Google form that you can fill out and submit your questions. And I also have some questions for you about what you're working on, because I'm really just trying to get to know people who are operating in this space and interacting with battery data. There's so many interesting problems and challenges in getting the most from battery data. And if we want to get to that sustainable battery value chain picture, we need to have a handle on our battery data and be using it, not let it just accumulate and do nothing with it. So thank you so much, everyone, for tuning in, and thanks for watching. Again, if you feel so inclined in the spirit of Thanksgiving, consider donating to my friend's GoFundMe to support her cancer treatment. I so appreciate you sharing that and paying it forward. That really means a lot. And again, hope to see you at our next webinar in a couple of weeks. We did get one more question in that I'll answer. So do you have a list of all tests possible and built in within that software? The answer to that is yes. Yes, please reach out and I can share more information with you about that. And tune into our live webinar in a couple of weeks and we can talk more about that as well. But getting that one-on-one meeting, I think, is the best way to learn more about all the bells and whistles it can do, especially for your operations, because the platform is so flexible that it can really be adapted to different settings, and new features are coming out all the time. So we got an exciting year coming up. Really, really excited about these kinds of solutions for battery data. So thank you, everyone, for joining in. If you have any last questions, pop them up. I'm about to, stop this live. And yeah, keep in touch, reach out. Happy to answer any questions, and take care. Have a wonderful holiday if you're in the United States, and I'll talk to you soon. Bye, everyone.